Ladies and gentlemen, my name is Trinh. Today I'm so glad to be here to present my project prosthetic for disabled people. First, the introduction and problem. I came from the Quảng province. After many years of the war, there are many disabled people, especially this hand is weak. So there are many problems in their daily life. So I create an idea to build an prosthetic to improve their life. On the market of the world, there are many products like this, but some of them are cheap, but have many limitations and smell is perfect but too expensive for the handicap. So the main purpose is create a prosthetic hand which cheaper and more useful for disabled people. Second, the material, method, and result of project. The processor of research of my project is first create the idea. The second, find out the material and electric device. The third, design the product and set up the handboard. Then code and build the main board. And finally, create and test the product. I design the product on sketch. I'm using 3D SketchUp to design the skin of the hand. And after designing, I using 3D printer to print the part of the hand, and after that I have to make the skin of the hand. How the hands working. The balloons of sensor after decode and analysis, decode and the command transfer through the RF wave 2.4 GHz and decode the command, and you control the hand robots. This is the size. This is the main part of the product, and its control is controlled by this transmitter. And calling, I using the C language in Arduino IDE, and this is the paragraph of my course. This is the picture of my project, and the main purpose of the project is to create a product which has a suitable price with the salary of those people. And this is my presentation. Thanks for following.
Thank you. Do you have any demo of the device? Video or something you can give a demonstration?
it is disabled people in my province.
Okay. What is the input signal of your sensor?
I use the transmitter. I use here is the touch sensor. It's the same as the smartphone screen, and I use this to you can use the push finger to control the hand finger, and here is the declination sensor, national sensor, and when you move the shoes like this, the hand will overthrow, and when you move the shoes like this, and the hand will moving like this.
So you do all the experiment on coding and choosing material, everything by yourself, right?
Yeah.
So at any point in the process, you wish to have a teammate. Have you ever want to have a teammate to do things with you?
I do everything single and with my teacher.
So you never want to have a teammate. You never want any friend to do things with you.
I have some friends on internet and they have me managing. Yeah.
So how long have you been testing your device?
I created this project for three years and testing for 1 year.
For 1 year only.
Yeah.
So is that a different person? You have to adjust the system, or you just use the same? They have the same response if you use for a different person.
This transmitter
Yeah.
is making by me.
Yeah.
Not.
No, but when because you use your system on a different person, for example, yeah.
Do you have the same
adjust it.
responses?
Another people they using the nervous system, nervous transmitter or Moscow sensor to control the hand, but it too expensive for the handicap. So I'm using this transmitter to making the prosthetic with more cheap and is with cheaper and more useful for the disabled people.
Are you certified? Are you happy with the system? Are you happy with the design now? Or you want to have more improvements? Are you happy?
Yes.
Okay. Sorry. No.
Just want to ask you, so is there any drawback of your system here, and in the future, if possible, which one you want to improve?
In the future, I want to control my hand by nervous system, but it is still very cheap and very useful for people, and it brings it to more and more disabled people, and it will improve their life.
How you can control it by the nervous system?
I'm using the nervous sensor to confirm the grant's way to the my main ball and using it to control my hand.
How much it cost?
It costs 3 million Canadian.
So do you think it is affordable for the disabled people in your hometown? Do you think it is affordable? I mean, they can buy it easily. Is that cheap or expensive? Cheap?
Yeah. This should go for the disabled people. While another other product on the market is with the same price is have many limitation and there are no electro device, but another is very expensive, about more than $100,000.
So no more question than that. So you done.
Yeah. Thank you.
Thank you.
Thank you.
Good evening, judges and audience. I would like to introduce my project, designing and making plasma producing systems applied in fabric field system. My project is divided into 5 parts. Firstly, motivation. Secondly, background. Thirdly, designing and making plasma producing systems applied in fabric field system. Firstly, experiment and result, and the last one is conclusion. About the motivation, I study textile and I find that in textile technology, they use a lot of water, chemical, and would produce a lot of pollution and harm the environment. So that to solve this problem, people have used the plasma technology to treat the surface of the fabric. Plasma technology is a physical method. It has no side effect. It saves the water and chemical and it is feasibility. The plasma treatment has gained the attention of many scientists as well as textile companies. We can consider some projects as innovative plasma technology in textile processing, a step to contribute environment, or project plasma treatment, advantage for textile and the use of atmospheric pressure plasma treatment on enhancing the application to control fabric. Let's show that the feasibility of this technique. Recently, I had a research in a textile company and we find the present process of dyeing fabric. Firstly is the pre-treatment surface. Secondly is the whitening. Thirdly is dyeing, and the last one is washing and drying. This process has many advantages and system is studied thoroughly and is widely. However, we have some disadvantages such as it is waste of water and energies and it requires high temperature and pressure. The second part is the application of technology in fabric treatment. Theoretically, plasma is considered to be the first step of matter after solid, liquid, and gas. When the matter is in the gas state gas state, if we continue to add the energy, the matter will change into the plasma state. The main properties of plasma is it is high energy and it produces just particles. In our research, we produce non-hemoplasma by using the edge barrier research. Our voltage is about 7 kilovolt and the frequency is 10 kilohertz. And the distance between the discharge is 3 millimeter, 4 millimeter, and 5 millimeter. After that, we test the distance between discharges. In the diagram, we can this is the plasma with the distance of two discharge is 3 millimeter, 4 millimeter, and 5 millimeter. We can see that with the distance of 5 millimeter, the plasma is very thin, and so that I try to create plasma with a distance of 3 millimeter and 4 millimeter. In the magnetic field,
ที่จะถามyour kind of nervous. So don't worry, take your time.
Yeah, more quickly.
Take a deep breath.
In magnetic field, ion and electron move with high kinetic, so that dust is removed by collision. Bacteria and fluids are killed by the UV ray, and the energized surface absorb metal. In our research in textile community, we find some similarity in the machine used that it include motor and cylinder. So that with the help of my teacher and the energy and our energy, we try to make a model in 3D of our system. In our system.
Drink water and stay calm.
Drink some water.
In our system, we create seven rows with different kinds, so that's the fabric, so that the fabric can move easily. Our system has three main parts. First of all is an engine and speed control system. The engine is used to rotate tire and it can control rotational speed. Secondly, the two discharges is either parallel, and the first discharge is covered by a layer of ceramic. Finally, is a cell of two discharges to change the distance between two discharges. And this is our model. After that, we take two kinds of fabric in a textile company. One in wool and one in wool, and the other is acrylic leaf. And this is the outcome. We can see that in the original sample. The leaf is covered. The leaf include dust, but after 10 minutes, the surface is completely different from each different. And the same result happened to the acrylic surface after 10 minutes treatment. In conclusion, our model shows some advantages. Firstly, it's save water and chemical. Secondly, it is connected to prison version of textile company. Thirdly, we optimize the surface property of metals. And finally, it shortens the dyeing time and enhance the pigment. In the future, we will do more research on the density of plasma as well as improvement the voltage and frequency circuit. And in application, we will try to improve the equipment to shorten the processing time, automate the plasma process by computer, increase the time and endurance, and finally the research on different textile. Thank you for your attention.
I thought you have a teammate.
Yes.
Thank you.
My partner is not confident to present English, so I present.
So you're also confident.
So the pressure is on you, right?
Bear the burden.
I have a question. So you say that the plasma can charge the surface of the textile
Yes.
before it's done. So can you say how can it help the dyeing process? And if it will have what kind of dye you need to use after that? After you charge the surface.
Thank you, John. And this is how plasma will twist the surface. The dust is removed by the conclusion, and the plasma field can produce UV ray which can kill bacteria and fluids, and the last one is the engine surface is absorbed better after the process. Can you repeat your second question? Can you repeat your second question?
Yes, sure. But okay. It charges the surface, right?
Yes.
Do you know what kind of charge? Negative, positive.
Can you clarify your question? Yes.
Because I would like to know how the charge surface of the textile can help in the dyeing process.
If it's smooth, it's better, or it needs to be rough to be better. The smooth one better, or rough.
If Italy is smooth, it will handle to say the water because the water will flat out. So that if the surface is more rough, the water can be set in its surface.
So it just soft physically, right?
Yes.
Is that effect to the property of textile because it changes the surface,
Just let me. As you can see, it's the only effect on the surface, a small on the small effect, and I think it will not change the property of the leaf.
You have any data to back it up? Any measurement, to prove that it will affect the property of the textile?
There are some science articles to prove that, but in my computer, and recently I had problem with it. It was lost. So you can use the internet to search it.
Okay, I have questions for you. So you said plasma is just another stage of the material, right? And plasma. Plasma is another stage of materials design via solid ligate, and it has very high energy. If so, do you think with different textile, with different properties and different chemicals inside, it may be affect a lot?
There are a lot of research in the world that show that the glass adjustment on the surface of different kind of fabrics such as cotton, acrylic, wool, or polyester has always show advantage effect, and the glass adjustment shows no disadvantage surface, so it won't change the property.
Are you sure?
That's what I do. Yes, I'm sure.
So when you roll over the textile, if the thickness of the textile change, do you think that the effective of the glass might change too?
Can you speak up?
When you roll over the textile, right, through the ruler, right,
Yes.
if the thickness of the textile increase, for example, do you think the plasma treatment is more effective or less?
Can you clarify your question?
If the thickness of the textile increase, for example, then the plasma treatment is more effective or less.
I think yes, but in textile company, the fabric always has thick 1 millimeter to 2 millimeters, so that it will not change much in the after treatment.
Okay, thanks.
Thank you. We have a conversation.
Can you please stand over there?
Các em bình tĩnh để lo lắng không?
Okay. Yeah.
Yeah. Afternoon, ladies and gentlemen. We are from, my name is Trinh, and this is my partner, Tieng. We are from Working High School. Today we are going to talk about study on some specificity effect, property, electroactivity, and time flows. There are 5 parts in our presentation today: general introduction, objectives, material and methods, results and discussion, conclusion and conclusion. About introduction. As you know, photocopying has 2 special layers, T and Phan. The lamp has many medical properties, including antimicrobial, antifungal, anti-cancer. Virus and no results, but low in the lab. The hepatitis protein are not diverse, and we have this economical values of this disease. Therefore, we have performed this project to study the active biological medical properties of 2 plant species and to reveal a specific variable properties. So the objective of our study are: the first one, perceptual evaluation of properties gathered from activity, plant fruits, and other components. The second one, quantification of some basic chemical compounds of properties and their components. And the last, evaluation of active biological properties of the properties.
And the next is the materials and method. About material, we have tea, pepperwood, and the other herbal, licorice, corn, spinel flowers, and white chrysanthemum. And therefore, experimental species include bacteria, E. coli, salmonella, fungus, mucor, mice, rat cancer cell lines and healthy breast cell lines.
We use three methods as follows. The first one, herbal tea production, making different herbal tea recipes, acceptable evaluation. The second one, modification of some acid chemical compounds, dry method of adduce method, total polyphenol, caffeine, and tannins. The last, evaluation of active biological properties of the substance, antibacterial properties, antifungal properties, antioxidant properties, reducing obese demand, and in vitro anti-cancer properties.
The next part is the results and discussion. We test on perceptible evaluation for herbal teas with dry material, then add the supplementary component, then making the filter base by filling tea leaves and palm fruit into the filter base. Then after that, incubated in boiled water at the 95 degrees in 3 minutes. Then finally, we conduct that perceptible evaluation from CT1, CT2, and CT3 properties. We choose CT3 for the downstream experiments. And this is about the quantification of some basic chemical compounds. To find out scientific foundation, we carry on analyzing some important chemical compounds, and we concluded that the dry matters and the dilute matter content of CT3 herbal teas is much higher than that of the other teas and palm fruit, and so do the total polyphenol content of CT3s. But the tannins and caffeine content of CT3s doesn't increase. It's similar to that of the olive. And this is about the evaluation of antibacterial properties. We use the method to measure the antibacterial rings, and in general, extraction from all kinds of tea leaf can suppress the growth of E. coli and Salmonella. Antibacterial properties of the olive is much higher than the middle-aged leaf and young leaf. Antibacterial properties of CT3 is similar to the olive and higher than the dry young leaf. The supplementary components have a low level of antibacterial properties, and you can see that the olive components of CT3 plays important roles in its antibacterial properties. The next is about the evaluation of antifungal properties. From the first 2 hours, you can see that the fungal spore didn't develop, but in the next 2 hours, they seem to develop quickly. But in the control environment, the fungal spore seems to be thicker. But in the CT3 herbal teas, they didn't develop. So it is clear that CT3 herbal teas strongly inhibit the growth speed of fungal mucor, similar to the olive and stronger than the middle leaf and young leaf. Next is about the evaluation of antioxidant properties. We use the ascorbic acid as the control chemical, and then we dilute the solution at the 400 times, 200 times, 100 times, and 25 times. And we can see that at 200 times, the CT3 has the strongest capacities of antioxidant properties. And now I'm going to talk about reduced obesities in mice. We chose wild mice, and they were divided into 4 groups: untreated obesities, and a half of CT3, obesities and 100% of CT3. And after 4 weeks,
blood obesities and heart obesity were significantly reduced compared to the group obesities. And to sum up that, CD3 hypothesis can reduce body mass of the experimental of these mice. And this is the most important application of our product is in vitro anti-cancer activities. For the healthy breast cell line, young and middle-aged live kill healthy cells at the concentration more than or equal to 5%. Young leaf can kill 100% cells at the concentration of 20%. The CD3 hypothesis and the olive only kill healthy cells at the concentration more than or equal to 20%. And so CD3 hypothesis and olive are safer for healthy cells than the young and middle-aged leaf. For breast cancer cell line, young leaf can kill more cancer cells than the middle-aged and old leaves. CD3 hypothesis kill more cancer cells than the other leaf and palm fruit. And so, at 5% supplementation, CD3 hypothesis kill nearly 50% cancer cells and doesn't affect the healthy cells. And healthy leaves are the most suitable for making hypotheses. And this is the part of
Conclusion. CD3 hypothesis including 80% of OTD, 20% of supplementary components, has highly score of perceptible evaluation. Total polyphenol and dilute method of CD3 hypothesis are higher than acetyl of tea leaf and palm fruit, but not for ratio of tannin and caffeine. The active biological properties of CD3 hypothesis inhibits growth of some bacterial species and spur virulent fungus mucosicinalis, strongly increase antioxidant activity compared to other tea leaves and palm fruits, reduce body mass and size of experimental obese mice. Nearly 50% of breeds has cells with 5% concentration with non-toxic force healthy cell in vitro. As plans for future, people analyze chemical composition of components of CD3 property for understanding the mechanics of these active biological properties. Evaluate for safety improve the production of CD3 properties, including service, color, and appearance. The final object of this project is creation of the healthy product for improve the income of local people.
This is our presentation. Thank you for attention.
How long have you done for this project?
We spent 8 months to produce this product.
Okay, just only 8 months.
8 months.
So, why you write on the box the expire date is 1 month? 1 year. Sorry, 1 year. So, the expire date of this product here you write on the box.
That means that have you test
You have to take.
the preservation
Yes,
at least for a year.
I spent 8 months to test on the biological properties of this product. So I spent only 2 days for produce this product.
It kills the bacteria, but it's not on most the bacteria. It just reduces the
Yes.
bacteria.
Yes.
So I think you should do more experiment before you write some information here.
Yes.
And what you think? What you should do to commercialize this product?
First, I think that I should give this to the Ministry of Public Health to to test and receive the certificates of Ministry of the Public Health. So I don't think about the commercial like this product now. So I hope that in the next times I will try.
I have a question. So you have done the perception test for the product, right?
Yeah.
But have you compared the new product with the normal tea leaf? Because does it increase the value of the perception, you know?
Yes. Thank you for your questions. This our products is combined with tea leaves and palm fruit, and the supplementary component, and this make our product easy to drink and
Is that easier?
yes.
Have you had the data, have the measurement to back it up that the new product is better for consumers? Consumer like it better. Any measurement like that? If no, that's okay. I just wonder.
Tell the truth. You tell the truth, you can say it. If not, you say no.
Can you repeat your question?
Okay, so have you measured, compared your new product with just normal tea leaf, you know?
Yes.
Whether the consumer like the new product better or not?
Yes, we test on my families and my neighborhood that they when they drink our products and they think that our product is better than the normal teas.
Yes, but because you've done the perceptible, you call it perceptible test, right? In that you can make a comparison. You can show some beginning slide. I saw that you have the perceptible test.
This?
No, earlier. So that when you create a formula for tea leaf and one supplement. Remember that? Here.
Yeah.
Yes, yes. This one.
Yes.
Evaluation. We call it perceptible evaluation. Yes. So this you usually let people drink and score
Yes.
the value, right?
So we have to test on the people
Yes.
who drink that.
And how they like it. Usually the score of how they like this one, right?
Usually is 8 or 10.
8 months.
They give our product.
Yes, score 8, but 8, right?
Yes.
Score 8, yes. But in this state, you can compare the new product with the
Yes.
non-new.
Good afternoon, judges. My name is Lemon Franco. We're from Amsterdam School from Pano, and today it's our honor to present our project, Unmodified Thuyet as a catalyst in the environmental processes applied for the treatment of persistent organic pollutants. First, our presentation today consists of 6 parts: introduction, objectives, experiments, results and discussion, conclusions, and lastly, potentials and future research. As you have already known, persistent organic pollutants cause many detrimental impacts on the environment, animals, as well as humans. So, treating is a big issue faced by society as a whole. To treat them, the oxidation process, which we depend on the strong and non-selective oxidative property of the hydrogen radicals, is known to be the most thermodynamic and the only solution in some cases. And along this process, the classical pattern reaction using iron 2 iron and H2O2 is the most common one. However, the process still has some disadvantages, including large amount of waste mass, catalytic retrieval property, and last but not least, high cost. To tackle this downside, our group has studied Thuyet, which is a byproduct of burning fossil fuel, and it has a very high amount of iron. the entry oxide is up to 8% of pollutants mass. And in this project, we have set 3 clear objectives. Firstly, successfully modifying and building the heterogeneous methane catalyst from fly ash and effectively treat piston-only pollutants. Secondly, optimize conditions for the treatment process. And lastly, contribute to settling the environmental problems regarding fly ash. If we can reach these goals, this will be the first time that fly ash is used as a heterogeneous methane catalyst to effectively treat piston-only pollutants. And this project also opens a new path for utilizing the other waste byproduct with a similar content as fly ash. And lastly, this project contributes to addressing many environmental problems.
These are some research objects that will be used in our project. Among these, reactive glue 182 is used in every step of this research. The modification process and treatment process is relatively simple. First, 4 grams of iron nitrate and 10 grams of fly ash is mixed into 20 milliliters of distilled water. The solution is then mixed and heated up to 100 degrees Celsius to remove all water. It will then be calcined in 500 degrees Celsius for 4 hours to obtain the catalyst. The catalyst will then be put into pH adjusted wastewater with hydrogen peroxide. It will then be mixed and the process will begin. Upon the completion of our research, we have reached some significant findings which we would like to briefly present as follows. Energy dispersive spectroscopies show that iron containing fly ash has increased significantly from approximately 4.4% to 9.8%, confirming that the modification process is successful. We have also studied several factors that influence the efficiency of the treatment process, such as pH, hydrogen peroxide concentration, catalyst dose, and temperature. And we have reached we have obtained these following results. The optimized pH is 3. The suitable catalyst dose is 1.0 gram per liter. The optimized hydrogen peroxide concentration is 3.92 mmol. To investigate the absorption ability and to evaluate the oxidation ability, we also conducted experiment with optimal condition, but without using H2O2. The results obtained with with low efficiency, only approximately 10% after 120 minutes of treatment, confirming that this process is mainly this wastewater is mainly treated due to the oxidation process. Also, based on the temperature, we have determined some kinetics factor. Activation energy is calculated to be 15.2 kilojoule per mole, confirming that iron impregnated fly ash is a promising catalyst for the depolarization of reactive glue 182 like dyes. Also, the UV spectra show that after 15 minutes, wastewater has completely discolored, and benzene structure has also been destroyed by the oxidation process. To determine the potential application of fly ash, similar process will apply with reactive blue 19, reactive yellow 160, plant protection chemical diazinon, and antibiotic amoxicillin, and have obtained very high efficiency from approximately 85% to 97%. And we also try to dye textile also from Zono textile and dye village, and we have obtained some very positive results. Degradation efficiency reached 97% after 60 minutes. In particular, catalysts can be retrieved and effectively reused for many times.
the project, which is some interesting findings. Firstly, fly ash can be successfully produced modified to simple impregnation process. Secondly, we found optimized conditions of this treatment process, and in this optimized condition, the efficiency of irradiation the resin flow 182 is 8% after 50 minutes. The activation energy of this process is 15.2 kJ per mole, which is pretty low, and it means that the process will occur easily. And next, the catalyst can be treated with kinds of persistent pollutants with very high efficiency ranging from 85 to nearly 100%. And lastly, catalyst can be reused many times, and furthermore, when we apply it on the industrial wastewater, the results are very positive. This catalyst can be used to treat a wide variety of persistent pollutants. And furthermore, this project also contributes to tackling the environmental problem regarding fly ash and open a new path for utilizing other byproducts with the similar content as fly ash. And lastly, to complete this project, next we will study the mechanism of the oxidation process and then investigate biologically degradation of the products after this oxidation process. And lastly, apply the results on a bigger scale. Thank you for your attention, and we're glad to answer any questions.
Okay, so I have a question. You say that your catalyst can be used many times. So can you show us the data? So how many times can it be used?
This is the efficiency of the fifth time, and it's very high. It's nearly like the first time we used it.
Okay, 5 times, right?
Can you go back to the slide that have the pH dependence? Okay, this one. So how do you come up with the conclusion that the pH equilibrium optimized pH is true? I thought 2 and 3 are kind of similar.
Well, because the pH ranging from 2 to 3 to have a very high efficiency. So the downside of this project is the low pH. So we have to choose the higher pH to reduce the cost, because we have to change from pH 7 to pH 3 and then return to release it to the environment.
It means when we use the pH 3, we use less acid to lessen the pH, and we use less the acid to increase the pH, which means that we can save a large amount of chemical use, and so it means you can save money.
Oh,
Yeah.
okay. Where did you get the funding for this project?
Well, this project we do most of the research on the school of my teacher, and well, he allowed me to.
BMU? It's all the experiments done there.
We have also sent some requests to other facility to get other research such as EDS.
Also makes other measurements.
Yeah.
Understand. Thanks.
Okay, I just have 2 questions for you. So, when you increase the concentrations of hydrogen peroxide, what happened? And what are your conclusions and explanation for that?
So when you increase enough, the efficiency will increase. But when you have too high amount of hydrogen peroxide concentration, it will act.
It will react with the hydrogen radicals that we need to use to treat the person only pollutants. So it means
So it's proved to reduce the efficiency of the process.
And just a second question. Very interesting there's only, I think, quite good conditions of the fly ash. Not only, another components. Can you tell me?
The homogeneous enzyme catalyst process has some disadvantages. So to tackle this downside, the scientists have used the heterogeneous tension process, which will tackle these two disadvantages. And however, the cost was still a problem. So to tackle this last disadvantage, we use fly ash, which is a waste product, and because it's a waste product, which means it's very easy to get and it's kind of free. So and it also has a large amount of iron inside. So we found a way to utilize this byproduct by using it to treat the wastewater.
Aluminum trioxide and silicon dioxide, the concentration is also very high. So it will affect your catalyst and the effect on the catalyst, or it just doesn't matter.
Many scientists around the world also study, and they found that the SiO2 and iron and the three oxide and iron is are both very effective tension catalysts. And in this in fly ash, we can also utilize these two oxides to increase the efficiency of the process.
Any more questions?
No.
I think we're done.
Thank you. Thank you. Yeah, thank you.
Shall we begin?
Yes, please.
Good afternoon, ladies and gentlemen. Today, we're very honored to present you a project on design, synthesis, and bioevaluation of novel hydrocyanic acids incorporated to oxoidolipholically as histone acetylase inhibitors and anti-cancer agents. Our project was conducted by Professor Nguyen Hai Nam from the Department of Pharmaceutical Chemistry, Hanoi University of Pharmacy. In this project, we're going to talk about the past and current anti-cancer drug design and development, HDACs, their classification, roles in cancer, and HDAC inhibitors, the design, synthesis, and biological evaluation, and preliminary docking of a series of hydrocyanic acids as novel histone acetylase inhibitors, and finally, we'll move to the conclusion and further researches on a new hydrocyanic acids. According to the Global Cancer Facts and Figures of 2014, 14.1 million new cancer cases are diagnosed every year, and about half of these, 8 million, occurred in economically developing countries like Vietnam, and 8.2 deaths were caused by this terrifying disease. This leads to the urgent needs of cancer medication. Nowadays, there are two methods of drug discovery, which are the traditional drug discovery and the molecular target-based drug discovery. However, the molecular target-based drug discovery saves about 1/3 of the time and reduces the cost by more than a half. Here are some of the current molecular targets for anti-cancer drug discovery, and today we're going to focus on histone acetylase, short for HDAC. HDACs are enzymes that catalyze the removal of acyl groups from the lysine residues of histone proteins. HDACs are divided into 4 classes. Based on the active site of HDACs, scientists have designed SAHA, short for soberol-alanine hydrocyanic acid. A compound has been clinically approved and widely used to treat prostate cancer. The inhibition mechanism of SAHA on HDAC is presented according to this graph. Our group has come up with a new series of compounds based on the structure of SAHA. However, we removed the benzene ring with the isoprene ring, and we added a triazole ring to the lipophilic linker, with expectations that our new compound's inhibitory activity will be increased. Once we've designed our compounds, we're moving on to the synthesis process. And Here is the synthesis of target hydrosulfuric acid. The first step of producing hydrosulfuric acid starting is something which is produced focusing bromide in DMF solvent by using potassium carbonate and potassium iodide as a catalyst. The reaction is performed at 80 degrees Celsius for 3 to 4 hours to form the compound series number 2. After the compound series number 2 is created, it is combined with acetomatic and chymeric acetomatic by using quick reaction and copper iodide as a catalyst. The reaction is performed at 50 degrees Celsius for 12 to 24 hours to form the series compound 3 and 4 which have triangle ring. Finally, is hydrosulfuric acid forming reaction between the compound series number 3 and 4 with hydroxyamine, hydrochloride in methanol tetrahydrofuran by using sodium hydroxide at minus 5 degrees Celsius for 30 minutes to form the compound series number 5 and 6. Here is the result of synthesis process. After we synthesize the target compound, we go from the structure by three types of special is IR, MS, and MR special. And here is IR special of compound 5E. And here is MS special of compound 5E. And this is a proton animal special of compound 5E. And this is current animal special of compound 5E. After we go from the structure of target compound, we study on bioevaluation. 14 compound was evaluated for cytotoxicity and ADAC2 inhibition activities. The results are table so that 14 compound can inhibit enzyme ADAC2 and cancer cells, especially the compound 5E, 5 to 8 times stronger than SAHA.
To get a preliminary insight of these compounds binding affinities towards HGAC, we received the help of Professor Han Yong-Wo from Seoul National University to perform the docking studies. And as you can see here, all the compounds had strong binding affinities towards HGAC2, as manifested by the values from minus 6.7 to minus 8.1 kilocalorie per mole. This value for SAHA was minus 7.4. Here is the stereo view of compound 5E bound to HDAC2 at the active binding site. In conclusions, two series of 14 hydrosulfuric acids incorporating two oxoanilines, compound 5A to 5G and 6A to 6G, were innovatively designed and successfully synthesized. The docking studies indicated that the compounds strongly bound to HDAC2 at the active binding site. These compounds boldly inhibited HDAC2 with IC50 values in sub-micromolar range, equivalent to that of SAHA. Compounds 5E, 5F, 6D, and especially 5E were up to 5.8-fold more cytotoxic than SAHA. For further research, we'll continue to evaluate the cytotoxicity and other bioactivities of the synthesized derivatives in vitro on other HDAC enzymes and other cancer cell lines in order to screen and potential derivatives for testing in vivo activity. And especially for compound 5E, we'll continue to conduct further biological testings such as tumor suppressor effects in animals, testing acute toxicity, chronic toxicity, stability, etc. for further clinical trials so that we'll be able to take this compound as a cancer treatment in practice. Thank you very much for your attention. We would love to hear your feedback.
Okay.
So what's the most favorite subject in school?
Mine is English and chemistry.
Can you go back to the IR spectrum slide? So what kind of information you can read from
The IR spectroscopy is a method to determine the functional groups of a compound. As you can see here, the peaks are also known as the wavelengths, which show us which compound it can represent by its value.
So the group,
Analyze.
can be more specific on that?
The IR spectrum provide information about the wavelength of functional group. And you can see the typical absorption pitch of NS is here. And the typical absorption pitch of carbonate is here.
The carbonate is from the environment or from the sample?
It's from the
to confirm the structures, what kind of measurement will you carry out?
First of all, during the synthesis process, we'll have to confirm it through thin layer chromatography.
Okay.
And also, we'll have to measure the melting points of these compounds. Once they're all done, we'll also have to measure it using the IR spectrum or infrared spectrum. We'll use mass spectroscopy, and this is the proton nuclear magnetic resonance, and here's the carbon nuclear magnetic resonance.
Okay, you can assign all the signal of the proton and the starting carbon and one on yourself.
Actually, this is a part that we also received the help from the pharmaceutical department of the Hanoi University of Pharmacy.
Okay, can you see, can you let me see the slide of the mass spectrum? Yeah, it's quite nice. But what is the peak of the target?
Here is the peak of the target.
Okay. So the molecular weight, I could not see really, I'm so sorry. Molecular weight.
The molecular weight is 381.1270.
Okay, so the next peak, the smaller one, like.
We are terribly sorry for the low resolution.
Oh, okay, it's fine. So the next peak, the design in the mass spectroscopy, there is another peak. It's around 20% compared with the target. What is that? The next one, smaller. Yeah, you have another peak on the mass spectrum.
As you can see here, the mass spectroscopy method is used by the electrospray ionization. And as you can see, this absorption peak is a peak from one of the ions that we collected during the spectroscopy measurements.
So it's not the byproduct from the synthesis.
No, it is not.
So I see that you have measured the yield of your synthesis reaction. Have you considered that it's a low yield or high yield? If it's a low yield, is there any way to improve it?
Our yields are from 60% to 75%.
Very high.
During the normal chemical synthesis process, this is a quite high yield. However, since our synthesis procedure is not totally complete, and in further future we will try our best to maximize the yield of these compounds.
How? Is there any way that you think you can improve further?
The way of changing the temperatures during the reactions, or we can change the time of the reaction.
Okay.
So you know there's many mechanisms of anti-cancer. So why you choose the enzyme histone deacetylase in your research?
As you can see here, long ago, the normal cancer medication method is to target both normal cells and the damaged cells. So in order to only target the damaged cells, we use histone deacetylase because histone deacetylase is one of the enzymes that determine the normal growth of the cells.
So it means for all kind of the cancer, all kind of the cancer, it's for that mechanism is not.
HDACs are usually found in tumors, and as you can see here, tumors are so much harder to cure than just normal cancer cells. So we are choosing this for our further researches.
Okay, thank you.
Thank you. You're finished.
Thank you very much.